section 6.3, vibration absorption. We've talked a lot about dampers, but that's not quite what we're talking about here. Dampers dissipate energy into heat. Sometimes we're fine with that energy sticking around. We just want to absorb it into a specific mechanism, right? This is actually a picture of the substation out by the soccer field, just south of campus here, under 300 Main. And what you'll notice is you have these, I believe that they're bus bars, right, coming off your three-phase power. And then you have these, I think these are called dog bones. These are kind of dog bone vibration absorbers. And what you have is a wire and two masses. And what they're designed to do is they're designed to pick up the energy at a specific frequency and more or less keep it there. They're not really dampers. Dampers require moving parts or some way to get things into heat. I mean, these will dissipate a little bit of heat and like the movements of the coil on itself, but it's not the key design parameter. The key design parameter is I'm okay with this damper vibrating as much as I want. They can be called a shock bridge damper or a dog bone damper, and that's the same thing here that you have on this system, and they can be on a cable. And maybe they just absorb the energy long enough at that specific frequency until whatever was exciting it dies out. These are on power distribution, and I wonder if they're tuned for 60 hertz because our grid infrastructure in the United States is 60 hertz. These are on a cable suspension bridge, so I wonder if they're tuned for something, that's kind of more dangerous to that cable suspension bridge. But these are vibration absorption. Vibration absorption is not vibration dissipation, right? I'm happy to just hold the vibration for as long as I need, and then eventually it'll dissipate into friction in the air. But the main aspect there is not trying to dissipate it as quickly as possible, but just trying to hold it at a specific frequency.